The F-22 Raptor has never lost a single air-to-air engagement, maintaining a perfect 108-to-0 kill ratio in combat exercises. The MiG-21 became the most produced supersonic fighter in history, with over 11,000 built. The F-15 Eagle achieved 104 victories with 0 combat losses across 5 decades of service. These aren't just statistics, they're the legacy of the most dominant fighter aircraft ever created. From Cold War legends to modern stealth monsters, these 10 warbirds redefined aerial combat and shaped the future of military aviation.
F-4 Phantom II, the double ugly legend.
A fighter so ugly it earned the nickname Double Ugly became the most produced American supersonic military aircraft in history, with 5,195 built between 1958 and 1981. The McDonnell Douglas F-4 Phantom II proved that raw power could overcome questionable aesthetics. This twin-engine beast could carry over 18,000 pounds of weapons on 9 external hardpoints, while reaching speeds exceeding Mach 2.2. Its cavernous air intakes and drooped nose gave it an ungainly appearance, but the Phantom's performance spoke louder than its looks. The aircraft set 15 world records for in-flight performance, including absolute speed and altitude records. The F-4's combat debut came during the Vietnam War, where it served as the principal air superiority fighter for all 3 U.S. services. Every American pilot who became an ace during Vietnam, 5 total, achieved their status flying Phantoms. The aircraft's versatility allowed it to excel in air-to-air combat, ground attack, and reconnaissance missions. What made the Phantom revolutionary was its multi-role capability decades before the term became common. Initially designed without an internal cannon, later variants incorporated the M61 Vulcan rotary cannon after Vietnam combat experience revealed the need for close-range firepower. The F-4's adaptability kept it relevant across multiple conflicts and with numerous allied nations. Despite its unconventional appearance, the Phantom became a signature aircraft of the Cold War, serving with 11 countries besides the United States. Its combination of speed, payload capacity, and technological advancement established the template for modern multi-role fighters. MiG-21, the People's Fighter. One aircraft has been flown by approximately 60 countries across 4 continents and still serves many nations 7 decades after its maiden flight. The Mikoyan-Gurevich MiG-21 Fishbed became the most produced supersonic jet aircraft in aviation history, proving that simple, effective design trumps complexity. The MiG-21's pencil-shaped fuselage and delta wing configuration created an aircraft that was both affordable and deadly. Its nickname Balalaika came from its planform resembling the Russian stringed instrument, while Vietnamese pilots called it On Bak, or Silver Swallow. This small fighter could reach Mach 2.05 and climb at 225 meters per second. What made the MiG-21 extraordinary was its operational simplicity. Unlike complex Western fighters requiring extensive maintenance, the MiG-21 was designed for rapid turnaround and minimal ground support. Its single Tumansky engine and straightforward systems allowed less developed nations to operate sophisticated supersonic fighters. The aircraft's combat record spans dozens of conflicts worldwide. During the Vietnam War, North Vietnamese MiG-21s proved formidable opponents against American F-4 Phantoms and F-105 Thunder Chiefs. The fighter's small size and high speed made it difficult to detect and engage, while its heat-seeking missiles proved effective in close combat. The MiG-21's longevity stems from continuous upgrades and modifications. Modern variants like the MiG-2193 incorporate advanced avionics and weapon systems while maintaining the original airframe's proven characteristics. This evolutionary approach kept the Fishbed relevant across multiple generations of aerial warfare. F/A-18 Hornet, the carrier warrior. The first aircraft designed from the ground up to be both a fighter and attack platform, the McDonnell Douglas F/A-18 Hornet revolutionized naval aviation by combining air-to-air and air-to-ground capabilities in a single airframe. This twin-engine marvel proved that versatility didn't require compromise. Entering service in 1983, the Hornet replaced both the F-4 Phantom and A-7 Corsair in U.S. Navy and Marine Corps service. Its unique design featured canted vertical stabilizers, leading-edge extensions, and a digital fly-by-wire control system that provided exceptional maneuverability at high angles of attack. The aircraft could remain controllable in flight regimes that would stall conventional fighters. The Hornet's combat debut during Operation Desert Storm demonstrated its revolutionary dual-role capability. Hornets shot down enemy fighters and bombed ground targets within the same mission, proving the concept of true multi-role operations. Aircraft that took direct hits from surface-to-air missiles successfully recovered, were quickly repaired, and flew again the next day, cementing the Hornet's reputation for survivability. Powered by twin General Electric F404 engines producing 17,750 pounds of thrust each with afterburner, the Hornet could reach supersonic speeds while carrying substantial weapons loads. Its 410 square-foot wing area and advanced flight controls provided the agility needed for both air combat and precision ground attack missions. The FA-18's carrier-based design requirements created an aircraft optimized for harsh operating conditions. Its robust landing gear, corrosion-resistant materials and folding wings made it ideal for naval operations, while its reliability and maintainability kept operational costs manageable throughout its service life.
Dassault Rafale, the French omni-role master.
While other nations built specialized fighters, France created an aircraft capable of performing every mission from air superiority to nuclear deterrence in a single sortie. The Dassault Rafale represents the pinnacle of European fighter design, combining advanced technology with operational flexibility. The Rafale's distinctive canard delta configuration provides exceptional maneuverability, allowing the aircraft to withstand forces from -3.6 G to +9 G in normal operations. Its aerodynamically unstable design requires digital fly-by-wire controls to maintain stability, but this instability provides the agility needed for modern air combat. The aircraft can fly as slowly as 15 knots during training missions while maintaining control. What really sets the Rafale apart is its domestically developed technology. The RBE-2 active electronically scanned array radar, Optronique Secteur frontal infrared search and track sensor, and direct voice input systems were all created specifically for the Rafale program. This technological independence allows France to upgrade and modify the aircraft without foreign restrictions. The Rafale's omni-role capability means it can switch between air-to-air and air-to-ground missions during flight without returning to base. Its 14 hardpoints can carry up to 21,000 pounds of weapons, including Meteor air-to-air missiles, Storm Shadow cruise missiles, and ASMP nuclear weapons. This flexibility makes each Rafale equivalent to multiple specialized aircraft. The aircraft's naval variant, the Rafale M, demonstrates French engineering excellence. Despite being carrier-capable, it retains 95% commonality with land-based versions and cannot fold its wings, a design decision enabled by France's nuclear-powered Charles de Gaulle carrier. This commonality reduces training and maintenance costs while maximizing operational flexibility.
Eurofighter Typhoon, the European collaboration.
4 European nations overcame decades of rivalry to create a fighter that could challenge American air superiority, resulting in the Eurofighter Typhoon, a twin-engine marvel that combines the best of British, German, Italian, and Spanish aerospace technology. This multinational collaboration produced one of the world's most capable air superiority fighters. The Typhoon's development began in 1983 as the Future European Fighter Aircraft Program, originally including France before disagreements over design authority, led to France's withdrawal to develop the Rafale independently. The remaining partners created a consortium of Airbus, BAE Systems, and Leonardo that continues to manage the program today. Powered by 2 engines producing 150,000 horsepower combined, the Typhoon can reach Mach 2.35 and climb to 11,000 meters in just 2 minutes. This exceptional performance makes it ideal for quick reaction alert missions, intercepting intruders before they can penetrate national airspace. The aircraft's canard delta configuration provides the agility needed for modern air combat scenarios. The Typhoon's combat record includes operations in Libya, where Royal Air Force aircraft participated in airstrikes destroying tanks in 2011 as their combat debut. The aircraft's precision strike capability, combined with its air superiority mission, demonstrates the multi-role flexibility that defines modern fighter design. With over 850,000 flight hours accumulated and 680 aircraft ordered by 9 nations, the Typhoon forms the backbone of European air defense. Export customers including Saudi Arabia, Oman, Qatar, Kuwait, and Austria demonstrate the aircraft's international appeal and operational effectiveness across diverse operating environments.
F-15 Eagle, the undefeated champion.
No fighter aircraft in history has achieved what the McDonnell Douglas F-15 Eagle accomplished. 104 air-to-air victories with 0 combat losses over 5 decades of service. This twin-engine air superiority fighter established a combat record that remains unmatched in modern aviation. Designed in response to the Soviet MiG-25 threat, the F-15 first flew in 1972 and entered service in 1976. Its massive twin Pratt and Whitney engines and advanced radar gave it capabilities that overwhelmed contemporary opponents. The aircraft's not-a-pound for air-to-ground design philosophy created a pure air superiority fighter optimized for one mission, controlling the skies. The F-15's combat debut came with the Israeli Air Force in 1979, where it quickly established its dominance. During the 1982 Lebanon War, Israeli F-15s achieved multiple victories against Syrian aircraft without suffering a single loss. This pattern continued in U.S. service during the Gulf War, where F-15Cs accounted for 34 of 37 Air Force air-to-air kills. What makes the F-15 extraordinary is its longevity. 50 years after its first flight, the aircraft remains in production with the F-15X variant. This latest version incorporates modern avionics, fly-by-wire controls, and advanced electronic warfare systems while maintaining the proven airframe that has never been defeated in air combat. The F-15's weapons capacity is legendary. The F-15EX can carry up to 22 air-to-air missiles, more than any other fighter in production. Combined with its APG-82 AESA radar and advanced electronic warfare suite, the modern Eagle remains a formidable opponent for any adversary aircraft.
Sukhoi Su-27, the Soviet Sky Dancer.
Soviet engineers created a fighter so agile it could perform maneuvers that, honestly, seemed to defy physics, challenging Western assumptions about aircraft design, and establishing the Sukhoi Su-27 flanker as arguably the finest air superiority platform of the 20th century. This massive twin-engine fighter combined size with grace in ways that really redefined aerial combat. Development began in 1969 as a direct response to the American F-15 Eagle, with chief designer Mikhail Simonov gradually refining the design into a masterpiece of aerodynamic engineering. The Su-27's distinctive shape, with its long fuselage, widely spaced engines, and graceful curves, created an aircraft that was both beautiful and deadly. The Su-27's performance specifications read like fantasy: Mach 2.35 maximum speed, 18,500-meter service ceiling, and a 3,530-kilometer range. More importantly, its thrust-to-weight ratio of 1.07, with partial fuel load, gave it acceleration and climb performance that matched or exceeded any Western fighter. The aircraft could pull plus 9G maneuvers while maintaining control at extreme angles of attack. What truly set the Su-27 apart was its maneuverability. The aircraft could perform the Cobra maneuver, pulling its nose up to 90 degrees or more while maintaining forward flight, demonstrating control authority that Western fighters just couldn't match. This super maneuverability came from its relaxed stability design and powerful flight control system. The Su-27's combat record, while limited, proved its effectiveness. Ethiopian Su-27s shot down 5 Eritrean MiG-29s during the Eritrean-Ethiopian War, demonstrating the flanker's superiority even over its intended partner aircraft. The Su-27's influence extends through its numerous variants, including the Su-30, Su-33, Su-34, and Su-35, each optimizing the basic design for specific missions.
F-22 Raptor, the Invisible Predator.
The F-22 Raptor, known as the Invisible Predator, achieved something truly unprecedented in modern aviation: a perfect combat record of 108 victories and 0 losses during realistic combat exercises. The Lockheed Martin F-22 Raptor stands as the absolute pinnacle of American aerospace technology, blending stealth, supercruise, and maneuverability in ways that, honestly, just redefined what air superiority means. The F-22's development kicked off in 1981 as the Advanced Tactical Fighter Program, with Lockheed Martin's design coming out on top in 1991. Its revolutionary mix of radar-absorbing materials, thrust vectoring, and integrated avionics gave it capabilities that, just a few decades earlier, would have seemed impossible. Stealth technology makes the F-22 almost invisible to enemy radar, allowing it to engage targets without ever being detected. And when you pair that with its ability to super cruise at Mach 1.5 without using afterburners, The Raptor can show up anywhere in the battle space, totally without warning. Its thrust vectoring engines give it maneuverability that outclasses even the most agile conventional fighters out there. But what really sets the F-22 apart is its combat systems integration. The radar, weapons control, and electronic warfare systems all work together as one seamless unit, providing pilots with situational awareness that gives them a huge advantage. During Exercise Northern Edge in 2006, F-22S racked up a 108-0 kill ratio against top F-15, F-16, and F-18 adversaries, all while maintaining a 97% mission capability rate. Production limitations make the F-22 pretty exclusive. Only 187 operational aircraft were built before the program wrapped up in 2012. This scarcity, along with export restrictions to protect its advanced tech, ensures the Raptor stays America's ultimate air superiority weapon. The aircraft's capabilities are so advanced it's expected to remain the U.S. Air Force's premier fighter well into the 2040s.
F-16, Fighting Falcon, the Global Guardian.
The F-16 Fighting Falcon, often called the Global Guardian, is the one fighter aircraft that serves with more air forces around the world than any other, proving that, sometimes exceptional design really does transcend national boundaries. The general dynamics. F-16. Fighting Falcon became the most widely used fighter jet on the planet, with over 4,600 built and flown by more than 25 nations. The F-16's revolutionary design brought fly-by-wire flight controls to production fighters, which allowed an aerodynamically unstable aircraft to pull off some pretty incredible maneuvers. Its side-mounted control stick and reclined pilot seat helped reduce G-force effects, letting pilots handle sustained high G-turns that would knock out pilots in more conventional jets. The bubble canopy offered 360-degree visibility that was just unmatched by any other fighter at the time. What really made the F-16 special was its lightweight design philosophy. Unlike the big, heavy F-15, the Fighting Falcon was all about being lightweight and affordable, but still able to outmaneuver bulkier opponents. Its single Pratt & Whitney or General Electric engine gave it a thrust-to-weight ratio over 1:1, so it could accelerate and climb faster than a lot of larger aircraft. The F-16's combat record covers conflicts all over the globe, from the Middle East to the Balkans. Israeli F-16S famously destroyed Iraq's Osirak nuclear reactor in 1981, showing off its precision strike ability, and during the Gulf War, F-16S flew more sorties than any other coalition aircraft, proving just how reliable and effective they really are. Continuous upgrades have kept the F-16 in the fight for 4 decades now. Modern versions feature ASO radars, advanced electronic warfare systems, and precision-guided weapons. The basic design is still so solid that new F-16S are still being built today, with the latest Block 70 and 72 models representing the very best in single-engine fighter tech.
FA-18EF Super Hornet, the carrier evolution.
The F/A-18E/F Super Hornet, known as the Carrier Evolution, is where Boeing took the proven Hornet design and turned it into something completely new. The Super Hornet is actually 25% larger than its predecessor, even though it shares the same designation. This leap forward gave us a fighter that combines the original Hornet's reliability with capabilities that can actually rival dedicated air superiority fighters. The Super Hornet was developed to address the original FA-18's limitations, all while keeping its proven strengths. The bigger airframe holds more fuel, which means it has the range needed for deep strike missions. Its more powerful F-414 engines deliver 22,000 pounds of thrust each, giving it supersonic performance even with heavy weapons loads. What really sets the Super Hornet apart is its electronic warfare version, the EA-18G Growler. It uses the same airframe but brings specialized jamming capabilities to the table. This means carrier air wings can keep their electronic warfare edge without needing totally different aircraft types, making logistics and training a whole lot simpler. The Super Hornet has seen combat in Iraq, Afghanistan, and Syria, where its precision strike power and survivability have been absolutely essential. Its advanced APG-79 AESA radar and integrated defensive systems give pilots the situational awareness they need in today's high-threat environments. Plus, its ability to serve as an aerial refueling tanker adds another layer to its multi-role flexibility. Even though it's called an upgraded Hornet, the Super Hornet actually shares less than 10% of its parts with the original FA-18. This major redesign created a jet that really performs like a new generation fighter, while still keeping the traits that made the Hornet so successful. The Super Hornet continues serving as the U. These 10 legendary fighters, honestly, they represent the evolution of aerial warfare from the Cold War right up to the cutting edge of the modern era. Every one of these aircraft pushed the boundaries of what was possible, from the Phantom's raw power to the Raptor's stealth revolution. They've defended nations, won wars, and inspired generations of aerospace engineers to reach even higher. The future of fighter aviation is going to build on the solid foundations these warbirds established. So which of these sky legends impressed you the most? Go ahead and share your thoughts below, smash that like button, and subscribe to Future Facts for more incredible stories about aviation excellence. Until next time, keep reaching for the sky. The United States military just successfully tested a missile that travels at nearly 3,836 miles per hour while maneuvering unpredictably through the atmosphere. American soldiers are already using augmented reality headsets that let them see through walls and around corners. Quantum computers are being developed that could crack any encryption in just seconds. These aren't distant dreams, they're operational realities transforming how America fights wars. Welcome to the cutting edge of military innovation, where science fiction becomes battlefield fact, and tomorrow's conflicts will be won by technologies that seem impossible today.
Hypersonic weapons, the unstoppable strike.
A weapon that can travel from New York to Los Angeles in under 30 minutes while changing course mid-flight to avoid any defense system. This isn't theoretical anymore. The United States Army's long-range hypersonic weapon, nicknamed Dark Eagle, has successfully completed end-to-end flight tests and represents America's entry into the hypersonic arms race. The Dark Eagle system consists of a massive rocket booster carrying the common hypersonic glide body, which separates at high altitude and glides toward its target at speeds exceeding Mach 5. Unlike ballistic missiles that follow predictable arcs, hypersonic weapons can maneuver throughout their flight path, making them virtually impossible to intercept with current defense systems. What makes hypersonic weapons revolutionary is their combination of speed and unpredictability. Traditional ballistic missiles give defenders time to react and follow known trajectories. Hypersonic glide vehicles can change direction, altitude, and speed while maintaining velocities that compress reaction times to mere minutes. This capability allows them to defeat anti-access and area denial systems that would stop conventional weapons. The Army plans to deploy Dark Eagle in 8 missile batteries, with each M983 truck carrying 2 missiles in launch canisters. The first operational unit at Joint Base Lewis McChord is expected to receive live rounds by May 2025, marking America's transition from hypersonic testing to operational deployment. The Navy's variant will equip Zumwalt-class destroyers and Virginia-class submarines, extending hypersonic strike capability across all domains.
Directed energy weapons, the speed of light arsenal.
Directed energy weapons, the speed of light arsenal. Imagine destroying incoming missiles, disabling enemy electronics, and neutralizing threats using nothing but focused light beams that travel at 186,000 miles per second. Directed energy weapons have moved from science fiction to battlefield reality, with the United States military deploying its first operational laser system aboard the USS Ponce in 2014. High-energy laser systems offer unprecedented advantages over conventional weapons. They provide virtually unlimited ammunition as long as power is available, eliminate logistical supply chains for projectiles, and deliver precise effects at the speed of light. Modern systems can engage multiple targets simultaneously while operating silently and invisibly outside the visible spectrum. The military has developed 2 primary categories of directed energy weapons: high-energy lasers for destroying physical targets and high-powered microwave systems for disabling electronics. Laser weapons excel at counter-drone operations, short-range air defense, and precision strikes against rockets and artillery. Microwave weapons can disable entire electronic systems without causing permanent damage to infrastructure. Current operational systems include truck-mounted laser platforms capable of destroying unmanned aerial vehicles and small boats. The Army's High-Energy Laser Scaling Initiative aims to develop more powerful systems capable of engaging larger threats like aircraft and missiles. These weapons represent a fundamental shift in military capability, providing commanders with precise, scalable effects that can be tailored to specific threats. The cost-effectiveness of directed energy weapons becomes apparent in sustained operations. While each laser shot costs only dollars in electricity, conventional interceptor missiles cost hundreds of thousands of dollars each. This economic advantage makes directed energy systems ideal for defending against swarm attacks and asymmetric threats.
Autonomous combat vehicles, the robotic battlefield.
Autonomous combat vehicles, the robotic battlefield. The United States military is developing unmanned ground vehicles that can navigate complex terrain, identify targets, and engage enemies without human intervention. But recent setbacks have forced a complete rethinking of autonomous warfare. The Army's Robotic Combat Vehicle program, launched in 2019, initially planned 3 variants but has been restructured due to evolving battlefield realities. The original RCV program envisioned light reconnaissance vehicles, medium support platforms, and heavy combat variants equipped with advanced sensors and weapon systems. These vehicles would operate alongside human soldiers, providing fire support and reducing risk to personnel. However, the war in Ukraine revealed critical vulnerabilities in slow, expensive robotic platforms targeted by cheap explosive drones. Current autonomous vehicle development focuses on practical applications rather than science fiction concepts. The ground vehicle. Autonomous Pathways project partners with commercial companies to adapt civilian self-driving technology for military use. Companies like Forterra, Kodiak Robotics, and Overland AI are developing navigation software that can handle diverse military environments. The shift toward practical autonomy emphasizes logistics and support roles over direct combat. Autonomous vehicles excel at supply missions, casualty evacuation, and reconnaissance operations where their ability to operate in dangerous environments without risking human lives provides clear advantages. These platforms can work continuously without fatigue and maintain operations in contaminated or hostile areas. Modern autonomous combat vehicles integrate artificial intelligence for navigation, obstacle avoidance, and mission planning. They can operate in GPS-denied environments using computer vision and terrain mapping while maintaining communication with human operators who retain ultimate authority over weapon systems. This human-machine teaming approach balances autonomous capability with human judgment.
Advanced cyber warfare capabilities, the digital battle space.
The US military fights wars in a domain that didn't even exist 50 years ago, cyberspace. Here, battles are won with code instead of bullets, and entire enemy networks can be destroyed without ever firing a shot. US Cyber Command has evolved into a unified combatant command, with 147 specialized teams conducting offensive and defensive operations around the globe. Cyber warfare capabilities now go way beyond traditional hacking. The military's cyber mission force includes teams that defend Department of Defense networks, protect critical infrastructure, and conduct offensive operations against adversary systems. These cyber warriors can disable enemy communications, manipulate enemy sensors, and, even cause physical damage to infrastructure through digital attacks. The Army's cyber units actually deploy expeditionary cyber and electromagnetic warfare teams to support tactical operations. These teams provide offensive cyber capabilities, information operations, and electromagnetic warfare support directly to combat units. They can jam enemy communications, intercept digital intelligence, and conduct cyber attacks that complement kinetic operations. Advanced cyber capabilities include artificial intelligence-powered threat detection, quantum-resistant encryption systems, and automated response mechanisms. The military is developing systems that can identify and counter cyber attacks in milliseconds, way faster than any human operator could respond. These systems use machine learning to recognize attack patterns and adapt defenses in real time. The integration of cyber operations with traditional warfare creates all new strategic possibilities. Cyber attacks can disable enemy air defenses before kinetic strikes, manipulate enemy logistics systems, and create confusion in enemy command structures. This multi-domain approach treats cyberspace as a maneuver space equal to land, sea, air, and space.
Next-generation stealth aircraft, the Invisible Armada.
The U.S. Air Force has confirmed the development of the F-47, a sixth-generation fighter that, honestly, makes the F-22 Raptor look like yesterday's technology. This revolutionary aircraft combines stealth capabilities that surpass current fighters with artificial intelligence systems that can command fleets of autonomous drones in combat. The F-47 represents the next-generation air dominance program's vision for the future of air warfare. Unlike previous fighters designed mainly for air-to-air combat, the F-47 integrates multiple mission capabilities including air superiority, ground attack, electronic warfare, and drone command. Its advanced stealth design potentially uses a tailless flying wing configuration, which minimizes radar signature beyond anything we've seen so far. What really sets sixth-generation fighters apart is their integration with autonomous systems. The F-47 can serve as a command node for collaborative combat aircraft, autonomous drones that extend the fighter's sensor range and weapons capacity. A single pilot could control several unmanned wingmen, multiplying combat effectiveness and reducing risk to human operators. The aircraft's adaptive cycle engines, potentially including the Pratt & Whitney XA-100, allow switching between high-speed performance and fuel-efficient cruising. This flexibility enables sustained operations over vast distances, while still maintaining the speed needed for air combat. The engine's variable cycle capability optimizes performance for different mission phases. Advanced avionics systems incorporate artificial intelligence to manage sensor data, coordinate with autonomous platforms, and assist pilot decision-making. The F-47's cockpit represents a fundamental shift from traditional controls to AI-assisted interfaces that can process information much faster than human operators, while still keeping humans in charge of critical decisions.
Soldier Augmentation Systems, the Enhanced Warrior.
American soldiers are already using augmented reality systems that overlay digital information onto their field of view, allowing them to see enemy positions through walls and coordinate with teammates through shared digital displays. The Integrated Visual Augmentation System, or IVAS, represents the most advanced soldier enhancement technology ever deployed. IVAS combines Microsoft's HoloLens technology with military-specific capabilities to create a comprehensive situational awareness platform. Soldiers can see thermal imagery, night vision, and digital maps overlaid on their natural vision, while also receiving real-time intelligence updates and communicating with their unit. The system even integrates with vehicle sensors, so soldiers can see outside before dismounting into dangerous areas. The latest IVAS 1.2 variant addresses earlier reliability issues and introduces improved sensors, plus a more comfortable form factor. The system can attach to combat helmets with a hinged mechanism similar to traditional night vision goggles, allowing soldiers to raise and lower the display as needed. Enhanced low-light sensors also improve target identification in tough conditions. Beyond visual augmentation, the military is developing physical enhancement systems. The Soldier Assistive Bionic Exosuit for Resupply, or SABRE, reduces lower back strain during heavy lifting operations. Recent tests show that 90% of soldiers reported enhanced task performance when using the exosuit during field training, which really demonstrates practical benefits for logistics operations. Current soldier augmentation is focused on enhancing human capabilities, not replacing them. These systems amplify natural senses, improve physical performance, and provide information advantages, all while keeping human decision-making authority intact. The ultimate goal is to create more effective soldiers, not robotic replacements.
Quantum Computing for Defense, the Ultimate Codebreaker.
The Pentagon is, racing to develop quantum computers that could solve in just minutes what would take traditional computers thousands of years, while at the same time preparing defenses against adversaries who might achieve quantum supremacy first. The Defense Department's quantum initiatives, honestly, represent both the ultimate weapon and the ultimate vulnerability in future warfare. Quantum computers exploit quantum mechanical properties like superposition and entanglement to perform calculations that are just impossible for classical computers. A cryptographically relevant quantum computer could, in theory, break current encryption systems that protect military communications, financial networks, and classified information. This capability would, render most current cybersecurity measures obsolete almost overnight. The military's quantum research is focusing on three primary applications: quantum computing for complex problem-solving, quantum sensing for detecting previously undetectable threats, and quantum communications for unhackable information exchange. Quantum sensors could potentially detect stealth aircraft, submarines, and underground facilities with unprecedented precision. DARPA's Quantum Benchmarking Initiative aims to determine whether industrially useful quantum computers can be developed faster than current projections suggest. The program evaluates quantum computing companies to, basically, separate legitimate progress from marketing hype while building verification capabilities to assess quantum claims. The Pentagon's quantum strategy emphasizes both offensive and defensive applications. While quantum computers could provide overwhelming advantages in intelligence analysis and cryptography, they also, threaten existing security systems. The military is developing post-quantum cryptography to protect against future quantum attacks, all while pursuing quantum advantages for American forces.
AI-powered battlefield management, the digital commander.
U.S. Marines in the Pacific are already using artificial intelligence chatbots to analyze surveillance data and identify threats, marking the beginning of AI's integration into real-time combat operations. This represents the second phase of military AI adoption, moving beyond simple automation to systems that can engage in human-like reasoning about complex battlefield situations. The Pentagon's Generative AI Task Force, led by the Chief Digital and Artificial Intelligence Office, is coordinating AI integration across all military services. Current applications include intelligent decision support systems that assist commanders in making tactical decisions, and aided target recognition systems that help identify enemy forces and equipment. Military AI systems are designed to augment human decision-making rather than replace it. The technology excels at processing vast amounts of sensor data, identifying patterns humans might miss, and providing recommendations based on comprehensive analysis. However, human operators retain ultimate authority over critical decisions, especially those involving weapons employment. Advanced AI applications include predictive maintenance systems that anticipate equipment failures, logistics, optimization algorithms that improve supply chain efficiency, and training simulations that adapt to individual soldier performance. These systems learn from experience and continuously improve their effectiveness through machine learning algorithms. The integration of AI with other emerging technologies creates synergistic effects. AI-powered systems can coordinate autonomous vehicles, optimize directed energy weapon targeting, and manage complex multi-domain operations. This convergence of technologies represents a fundamental transformation in how military operations are planned and executed.
Advanced electronic warfare systems, the invisible shield.
The U.S. military is deploying electronic warfare systems that can jam enemy communications across entire regions while simultaneously protecting American forces from similar attacks. These systems represent a new generation of electromagnetic spectrum dominance that treats radio waves as both weapons and shields in modern warfare. Electronic warfare encompasses three primary areas: electronic attack systems that disrupt enemy electronics, electronic protection measures that defend friendly systems, and electronic support activities that gather intelligence through electromagnetic monitoring. Modern systems can operate across multiple frequency bands simultaneously while adapting to enemy countermeasures in real time. The Army's expeditionary cyber and electromagnetic warfare teams provide tactical electronic warfare capabilities directly to combat units. These teams can jam enemy communications, disrupt unmanned aerial vehicle operations, and protect friendly forces from electronic attacks. Their equipment includes portable jammers, signal intelligence systems, and cyber warfare tools. Advanced electronic warfare systems use artificial intelligence to identify and counter enemy electronic systems automatically. These systems can recognize enemy radar signatures, communication protocols, and electronic warfare techniques while adapting their countermeasures accordingly. The speed of electronic warfare requires automated responses that operate faster than human reaction times. The integration of electronic warfare with cyber operations creates new possibilities for disrupting enemy forces. Electronic attacks can disable enemy sensors while cyber operations manipulate the data those sensors collect. This combined approach can create false pictures of the battlefield while blinding enemy forces to actual American positions and movements.
Space-based military assets, the ultimate high ground.
The U.S. military is deploying satellite constellations that can track hypersonic missiles, provide global communications, and potentially engage targets from orbit, establishing space as the ultimate military domain. The Space Force's development of next-generation satellite systems represents a fundamental shift in how America projects power globally. Military space assets provide essential capabilities including GPS navigation, secure communications, intelligence gathering, and missile warning systems. Modern satellite constellations use distributed architectures that make them more resilient to attack while providing global coverage. These systems enable precision weapons, coordinate joint operations, and provide real-time intelligence to forces worldwide. The military is developing responsive space launch capabilities that can deploy satellites within hours of need. This rapid deployment capability ensures continued space-based support even if existing satellites are destroyed or disabled. Small satellites and CubeSat swarms provide redundant capabilities at lower cost than traditional large satellites. Space-based sensors can track threats that ground-based systems cannot detect. Satellites equipped with infrared sensors can identify missile launches anywhere on Earth within seconds, providing early warning of hypersonic weapons and ballistic missiles. Advanced space telescopes can monitor adversary activities and provide intelligence for military planning. The weaponization of space remains controversial, but the military is developing defensive capabilities to protect American satellites from attack. These systems include satellite-based interceptors, electronic warfare capabilities, and maneuvering satellites that can avoid hostile actions. The goal is maintaining American space superiority while deterring adversary space weapons. These 10 revolutionary technologies represent America's commitment to maintaining military superiority in an increasingly complex world. From hypersonic weapons that arrive without warning to quantum computers that could reshape cryptography forever, each innovation addresses specific challenges while creating new possibilities for future warfare. The convergence of these technologies will define military power for the next 50 years, ensuring American forces remain unmatched on tomorrow's battlefields. Which of these game-changing innovations impressed you most? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible military technology stories. Until next time, stay curious about the future. For over 3 decades, the Soviet Union became obsessed with Venus, launching more than 20 missions to humanity's closest planetary neighbor. Between 1961 and 1983, Soviet engineers sent probe after probe to a world where surface temperatures reach 462 degrees Celsius, and atmospheric pressure crushes objects like a deep-sea trench. Despite catastrophic failures, the Venera program achieved historic firsts, including the first images from another planet's surface. But buried in classified reports were tantalizing hints of something extraordinary, potential signs of microbial life in Venus's hostile atmosphere. Today, we uncover what Soviet scientists really discovered on the morning star.
The first assault on hell.
The Soviet obsession with Venus began with spectacular failure. Venera 1, launched on February 12, 1961, was humanity's first attempt to reach another planet, but contact was lost after just 7 days in space. The probe sailed past Venus in silence, becoming space's first ghost ship. Soviet engineers, led by chief designer Sergei Korolev, refused to surrender to this hellish world. Over the next decade, they launched mission after mission, each one teaching them harsh lessons about interplanetary travel. Venera 2 and Venera 3 also failed, but Venera 4 in 1967 became the first spacecraft to transmit data from Venus's atmosphere during descent. The probe revealed crushing pressures and scorching temperatures that exceeded all predictions. By 1970, Venera 7 achieved the impossible, surviving Venus's surface for 23 minutes while transmitting temperature readings of 475 degrees Celsius. This success marked the beginning of the most ambitious planetary exploration program in human history, as Soviet scientists prepared to unlock Venus's deadly secrets.
First pictures from another world.
October 1975 brought humanity's greatest planetary exploration triumph. Venera 9 descended through Venus's crushing atmosphere and, against all odds, survived long enough to transmit the first photograph from another planet's surface. The grainy, black-and-white image revealed a landscape of jagged rocks and flat stone slabs, illuminated by the dim orange glow filtering through Venus's thick clouds. Venera 10 followed 3 days later, capturing more surface images from a different location. These photographs stunned scientists worldwide. Venus wasn't the molten hellscape many expected, but a rocky world with surprising geological diversity. Mission director Vsevolod Abduevsky noted unusual atmospheric readings during the descent, including unexpected chemical signatures that some Soviet researchers quietly interpreted as potentially biological in origin. The landers survived for over an hour each, far exceeding design specifications and proving that sophisticated exploration of even the most hostile worlds was possible. These historic images opened the door to more ambitious missions that would soon detect mysterious compounds in Venus's deadly atmosphere.
The chemical anomalies.
Soviet scientists discovered something puzzling in Venus's atmosphere that defied easy explanation. Venera 11 and Venera 12, launched in 1978, carried sophisticated gas chromatographs and mass spectrometers designed to analyze atmospheric composition during descent. The instruments detected unexpected organic compounds, carbon-based molecules that shouldn't exist in Venus's hostile environment. Dr. Boris Surkov, the mission's chief chemist, reported finding sulfur-bearing organics and phosphine compounds in concentrations that couldn't be explained by known geological processes. Most intriguingly, the probes detected rapid chemical reactions occurring in Venus's middle atmosphere, approximately 50 to 60 kilometers above the surface, where temperatures dropped to a more habitable 0 to 60 degrees Celsius. Soviet biochemist Leonid Mukhin argued these reactions showed signs of metabolic activity, the signature of living organisms processing chemicals for energy. Western scientists remained skeptical, attributing the findings to instrument contamination or unknown atmospheric chemistry. But classified Soviet reports suggested something more extraordinary. Venus's clouds might harbor extremophile microorganisms adapted to the planet's sulfuric acid environment.
Life in the clouds.
The most startling Soviet discovery came from studying Venus's upper atmosphere where, conditions dramatically improve. At altitudes of 50 to 60 kilometers, atmospheric pressure equals Earth's sea level, and temperatures range from 0 to 80 degrees Celsius, potentially habitable for extremophile life forms. Venera 13 and Venera 14, launched in 1981, carried biological detection equipment including microscopes and soil analysis chambers. The landers detected rapid oxygen depletion in atmospheric samples, suggesting active chemical or biological processes. Soviet astrobiologist Gavril Tikhov had long theorized that Venus's clouds could support sulfur-based life forms, and the Venera data seemed to support his hypothesis. The probes found droplets containing complex organic molecules suspended in the acidic clouds, including amino acid precursors and lipid-like compounds. Most remarkably, these organic materials showed isotopic ratios inconsistent with purely geological formation. Dr. Roald Sagdiv, director of the Space Research Institute, privately reported that the findings suggested, quote, active biological processes, end quote, occurring in Venus's atmosphere. However, the extreme secrecy surrounding Soviet space biology meant these extraordinary claims remained largely hidden from international scrutiny for decades.
The phosphine mystery.
Soviet atmospheric analysis revealed one of the most intriguing chemical mysteries in planetary science. Venera 15 and Venera 16 orbiters, deployed in 1983, used infrared spectrometers to map atmospheric composition across Venus's entire globe. The instruments detected significant concentrations of phosphine gas, or pH3, in the planet's clouds, a compound that shouldn't exist in Venus's oxidizing atmosphere. Dr. Mikhail Marov, the mission's principal investigator, noted that phosphine breaks down rapidly in the presence of sulfuric acid and should disappear within minutes. Yet the gas persisted at levels of 10 to 20 parts per billion, suggesting continuous replenishment from an unknown source. On Earth, phosphine is produced almost exclusively by anaerobic bacteria living in oxygen-free environments. Soviet microbiologist Alexander Imshinetsky conducted experiments showing that certain terrestrial microorganisms could survive in sulfuric acid solutions similar to Venus's clouds. The persistent phosphine detection became classified information, but leaked reports suggested Soviet scientists believed they had discovered the first evidence of extraterrestrial life. This finding would remain buried in classified archives until recent international missions rediscovered phosphine in Venus's atmosphere.
The biological instruments.
Few people know that Soviet Venus landers carried sophisticated biological detection equipment designed specifically to search for life. Venera 13 and Venera 14 included automated microscopes capable of magnifying samples 500 times to detect cellular structures. The landers also carried enzyme detection chambers that could identify metabolic byproducts produced by living organisms. Mission biologist Dr. Wolf Vishniak, working with Soviet scientists, designed experiments to detect microbial respiration by measuring changes in gas concentrations over time. The results were extraordinary. Soil samples showed rapid chemical changes consistent with biological activity, including pH fluctuations and organic compound synthesis. Venera 14 detected what appeared to be microscopic structures resembling bacterial colonies in atmospheric condensation samples. Soviet scientists also found diurnal variations in atmospheric chemistry that suggested day-night cycles of biological activity. However, contamination concerns and instrument limitations prevented definitive conclusions. Dr. Carl Sagan, who collaborated with Soviet researchers, privately acknowledged that the data was, quote, tantalizingly suggestive, end quote, of biological processes, but cautioned that extraordinary claims required extraordinary evidence that the harsh Venusian environment made nearly impossible to obtain.
The temperature paradox.
Soviet missions revealed a shocking truth about Venus's atmospheric layers that really challenged assumptions about planetary habitability. While the surface reaches 475 degrees Celsius, hot enough to melt zinc, the upper atmosphere tells a completely different story. Venera atmospheric probes discovered that between 48 and 70 kilometers altitude, temperatures drop to Earth-like ranges of -10 degrees to +60 degrees Celsius. In this so-called Goldilocks zone of Venus's atmosphere, pressure equals Earth's sea level and water could in theory exist as liquid droplets suspended in the clouds. Soviet atmospheric physicist Mikhail Avduevsky calculated that this habitable layer actually extends across Venus's entire globe, creating a planet-wide aerial biosphere that's even larger than Earth's total land surface. This discovery really revolutionized thinking about where life might exist in the solar system. Venera 15 and Venera 16 radar mapping missions detected atmospheric convection patterns, suggesting complex weather systems in this habitable zone. Most intriguingly, the probes found chemical gradients that appeared to be maintained by unknown processes, possibly biological ones. This temperature stratification meant Venus might harbor more habitable volume than any other planet except Earth, hidden within its deadly atmospheric envelope.
The cover-up controversy.
The Soviet Union's secretive approach to space biology created decades of speculation about what they really discovered on Venus. Classified reports from the 1980s, released after the Soviet collapse, revealed that multiple Venera missions detected anomalous biological signatures that scientists just couldn't explain through known chemistry. Dr. Roald Sagdaev later admitted that Soviet space officials suppressed potentially groundbreaking discoveries to avoid international embarrassment if the findings proved false. Internal memos from the Space Research Institute described biological anomalies detected by Venera 11, 12, 13, and 14 that suggested active metabolism in Venus's clouds. The most controversial claim came from mission scientist Leonid Sanfomality, who reported finding moving objects in Venera surface images that appeared to change position between photographs. He interpreted these as possible primitive life forms adapted to Venus's extreme surface conditions. However, peer review and image analysis by other scientists suggested these were likely instrument artifacts or wind-blown debris. The lack of transparency around Soviet biological experiments means that potentially revolutionary discoveries may have been lost forever in classified archives, fueling decades of speculation about hidden evidence of Venusian life.
Modern vindication.
Recent international missions have validated many controversial Soviet claims about Venus's potential for life. In 2020, radio telescope observations confirmed the presence of phosphine gas in Venus's clouds, the same compound Soviet scientists detected in 1983 but couldn't publish due to classification restrictions. Dr. Jane Greaves of Cardiff University led the modern phosphine discovery, measuring concentrations of 20 parts per billion at 55-kilometer altitude, exactly matching unreported Soviet data from the Venera missions. This vindication has prompted scientists to reconsider other dismissed Soviet claims about biological activity in Venus's atmosphere. NASA's planned Veritas mission and ESA's Envision orbiter will carry advanced spectrometers to search for the organic compounds and metabolic signatures that Soviet instruments may have detected decades earlier. Modern computer modeling shows that extremophile microorganisms could indeed survive in Venus's cloud layers, feeding on sulfur compounds and carbon dioxide. The rehabilitation of Soviet Venus research has transformed our understanding of planetary habitability, suggesting that life might exist in environments previously considered impossible. Venus may indeed harbor the first confirmed extraterrestrial life, hidden in plain sight for over 40 years.
The enduring mystery.
The Soviet Venera program's legacy extends far beyond its technological achievements to fundamental questions about life in the universe. Over 22 missions spanning 2 decades, Soviet scientists gathered more data about Venus than any other planetary body except Earth. Their discoveries of organic compounds, phosphine gas, and atmospheric chemistry consistent with biological processes remain some of the most intriguing findings in planetary science. Dr. Sarah Seeger of MIT calls the Soviet Venus data the most underappreciated dataset in astrobiology, noting that modern analysis techniques could extract revolutionary insights from 40-year-old measurements. The recent phosphine confirmation has sparked renewed interest in Soviet archives, with researchers discovering previously classified spectrometer data showing complex organic molecules and isotopic signatures suggestive of biological activity. While definitive proof of Venusian life remains elusive, the accumulated evidence suggests our nearest planetary neighbor may not be the sterile hell world we assumed. As new missions prepare to return to Venus, they carry the hopes of finally answering the question Soviet scientists posed decades ago: could life exist in the clouds of our sister planet? The Soviet Union's decades-long exploration of Venus produced tantalizing hints that our sister planet might harbor life in its acidic clouds. From phosphine gas to organic compounds and unexplained chemical reactions, Soviet scientists detected phenomena that modern research is only now beginning to understand. While definitive proof remains elusive, the mounting evidence suggests Venus deserves serious consideration as a potential habitat for extremophile life. Which Soviet Venus discovery surprised you most? Drop your thoughts below. If you enjoyed uncovering these planetary mysteries, hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible scientific revelations.